Hello everyone and welcome back to the channel. If you're building a SaaS application or managing a large multi-account AWS environment, you've probably faced this problem. How do you expose a private service in one VPC to consumers in a completely different VPC in a different account entirely without exposing it through the public internet and without dealing with the nightmare of overlapping IP addresses or even complex transit gateway routing or setup? This sounds impossible, but AWS has a service built specifically for this. And the answer is AWS PrivateLink. It's the exact same technology AWS uses to privately expose their own services to, like the S3 and DynamoDB, inside your own VPC. In today's project, we are building a production-ready AWS PrivateLink architecture that allows applications in one VPC in an AWS account to privately consume services hosted in another VPC in another AWS account without internet access, without NAT gateways, without transit gateways, and without VPC pairing. We're going to be building both a service provider VPC in a different provider account and also a service consumer VPC in a different consumer account. Expose the application using network load balancing, publish it through an endpoint service, and then securely connect to it using an interface VPC endpoint. By the end of this video, you understand why AWS PrivateLink has become one of the preferred methods for private service connectivity in enterprise AWS environments. Before we jump into the console, let's look at what we're going to be building. But before we jump into that, if this is your first time watching these videos, please like and subscribe. This helps anyone preparing for AWS exam or trying to learn about AWS get this video and then learn more about it. But right now, let's jump into the architecture, and then I'll show you what we're going to be building and also the real world scenario we're going to be emulating. And here is the architecture we're going to be building today. On the left side of the architecture is our service provider VPC. It's going to be in a different account, while on the right hand side we have our consumer VPC. Think of this as the company hosting an internal application that our AWS accounts or VPCs need to consume. In this VPC, we have a fleet of instances running a REST API. Instead of allowing clients to connect directly to the instances, AWS requires us to place a network load balancer or NLB in front of the service. The NLB becomes the entry point for all incoming private link traffic. And here we have the endpoint service. This endpoint service is attached directly to our network load balancer. Think of it as publishing the application privately to AWS. AWS generates a unique service name that other VPCs can connect to. At this point, the application still is not publicly accessible. Only approved consumers can connect to this application. And then we have the interface endpoint. Creating the interface endpoint automatically deploys one or more elastic network interfaces or ENIs inside the consumer VPC. These ENIs receive private IP addresses directly from the consumer VPC's subnet. Now, to the application running in the consumer VPC, it appears as though the services exist locally inside its own network. And then AWS creates a private DNS name for the interface endpoint. When our consumer application here performs a DNS lookup, it resolves to the private IP address of the endpoint inside its own VPC. So the application has no idea the actual service is hosted somewhere else. It thinks it's hosted in its own VPC. Now the traffic flow is where the magic happens. The application sends traffic to the interface endpoint. Now AWS intercepts this traffic and securely transports the traffic across the AWS backbone network. The traffic arrives at the producer network load balancer. The network load balancer now forwards the request to the backend EC2 service, which is going to be the applications hosted on our provider VPC. The response allows the exact same path back to the consumer. The same path it came in, that's how it's going to go back. Through all this traffic, at no point does this traverse the public internet. Everything is well within the AWS backbone network. So our real world application we're going to be simulating in this project is going to be a secure patient data hosted in a hospital environment. We have a hospital that hosts patient records in one VPC in a different account, and this account is going to represent the producer account, right? So they host the patient records in a particular account, in a particular VPC, in a particular account. And then to stay HIPAA compliant, other applications need to come and access this VPC from their own account. So we have accounts like EMR accounts, the electronic medical records accounts, the billing accounts, the imaging accounts, the lab accounts. Imagine this in the hospital, right? When you go to the lab and the lab needs to access your patient record, instead of creating a different transit gateway or VPC pairing for all of these applications, right? You just have one singular account in a VPC that hosts all the patient records, and then all the other applications use the private link to access this and then get the patient record. And this is going to be a one direction access. The applications are accessing this, but the producer cannot access these applications. So the traffic flow is simple. Application initiates the request to the patient record. So our application initiates the request. The request goes through the VPC endpoints, through the private link, and then AWS network backbone routes the traffic. Request reaches the patient records API, and then response returns through the same secure path back to the application. Why is this important? Imagine we have to meet some requirements, for example, HIPAA compliance. This is HIPAA compliant because all applications just have one read-only access to this, to the patient records. They can't modify anything, just have read access only to it. There is no internet access. Applications cannot communicate. They just read and that's it. Only patient records API is reachable, nothing else. So you're just exposing what you want them to have access to. And the key benefit of this is maximum security, regulatory compliance, reduced attack surface, and also operational efficiency. This also enables audit log because we can see all applications accessing the patient records and every traffic is encrypted. So now let's jump into the AWS console and go ahead and build some. Here on the AWS console, before the deployment, you want to ensure that the following prerequisites are met. One is an AWS account with administrative permissions. Using two separate AWS accounts, one for the provider and one for the consumer, is highly recommended. This will fully simulate the real world use case and understand cross-account permissions. And two is going to be the IAM permissions. The user or role executing these steps must have the permissions to create and manage VPCs, EC2 instances, network load balancers, and VPC endpoints and endpoint services. 3 is going to be the network infrastructure. We need to set up two VPCs, one in the provider account and the other in the consumer account. You can use this in the same account or different account, but best practice is to use different accounts. Each VPC should have at least one public subnet for SSH to the instances and then one private subnet for the service endpoint. So now the first thing we should do is to make sure we have the prerequisite set up. For me here, I have two different accounts I'm going to be using. One is my management account, which is in 094, and then 2 is my networking account, which is going to be the 9566 here. So I have two different accounts I'm going to be using for this project. So what I'm going to do now is, first of all, create VPC in the producer and then in the consumer account. This right here, my management account, is going to be the producer, and then this is going to be my consumer account. And just so we can differentiate between the two accounts, my producer account is going to be with the red ribbon, and then my consumer account is going to be with the green ribbon. So let's go back to the producer account, and then we're going to be creating our VPC. And when creating our VPC, we're going to be using overlapping CIDR blocks, just so you understand that this private link does not mind overlapping CIDR blocks. So let's go ahead and create VPC. Now we're going to be creating VPC with one private subnet and one public subnet for each account. So for this, I'm going to just go VPC and more, and this is going to be, and then this is going to be my producer VPC, and I'm going to use /16. I'm going to use one availability zone, so I need one public and one private subnet. And for this project, we don't need a NAT gateway. We need VPC endpoint but not the S3 gateway. And then we're enabling DNS hostname and resolution here. Let's go ahead and create. Now while this is happening here in the producer account, let's replicate the same thing in the consumer account. So let's go to VPC, let's create VPC, and then this is going to be consumer. One AZ, one public, one private, same thing, and then create. So now that we've created the two VPCs in the two accounts, let's start with the producer account now and set up the account. So we're going to be deploying our actual services and the necessary infrastructure to expose our service via the private link. So the first thing we should do is to launch a provider service, which is going to be an EC2 instance. So in the provider, which is our Red Ribbon, let's go to EC2. So I'm just going to come over, since I'm right here, I'm just going to go over to the VPC dashboard and launch an instance. And this, we're going to name our instance. I'm going to use the Amazon Linux. And then for this, let's create a key pair. Let's generate a key pair. We're going to name this key pair private key pair, and then go ahead and create. And then for the networking, let's edit our networking, pick our VPC we just created, and then let's select our subnets. We're going to select our private subnets. For the auto assign public IP is going to be disabled since it's a private subnet. And for the security group, we're going to be creating a new security group, and we're going to name this security group provider security group. We're going to allow SSH, and then we're going to add another role to allow port 80, and it's going to be from our VPC CIDR. And then let's go to advanced details. Here we're going to be using the user data. Just scroll all the way down. I'm going to copy my user data and paste it right here. Now this instance is going to represent our backend application that consumers need to access. This is going to represent healthcare PHI that other applications you need to consume. So placing it in a private subnet ensures that it cannot be accessed directly from the internet, which is HIPAA compliant, and then also adhering to security best practices. User data script here automatically provisions a web server to respond to consumer requests. So in the real world, this is going to represent our PHI in a private subnet. So what this one is essentially doing is just saying welcome to the secure provider service via private link. And then let's go ahead and launch the instance. While the instance is launching, let's go to target group. To load balancer, go to target groups. And we're going to be creating a target group, and this is going to be for instances. We're going to name it the provider service target group, and the protocol we're going to be using, we're going to use TCP on port 80. We're using TCP because we're going to be deploying a network load balancer. It's going to be IPv4. And then for VPC, we're going to select our VPC and then click next. We're going to select our instance, include as pending below, and then next, and then go ahead and create target group. The target group here acts as a logical grouping of our backend targets. And this in the real world is going to be different applications that host different targets that host, or different EC2 instances that host our PHI. And it tells the network load balancer exactly where to route incoming traffic. So using the TCP protocol is required because private link operates at layer 4, remember, which is going to be the transport layer of the OSI model. So next thing we're going to do is to create our network load balancer. So come to load balancers here, drop this, and then create network load balancer. We're going to name our network load balancer. Since it's routing to private IP address, it's going to be for internal. And then for the VPC, we're going to select our VPC and then our availability zone. And there we have our subnets. And then we're going to select our security group. And for the listeners and routing, we're going to select TCP port 80. And then for the target group, we're going to select the target group we created right now. And then just scroll down and create load balancer. And the reason why we're creating the network load balancer is because private link explicitly requires a network load balancer to act as the entry point to the endpoint service. So selecting an internal scheme is crucial because it ensures that the network load balancer does not receive a public IP address, keeping the entire traffic flow private and isolated from the internet, which is the main point of building this architecture. So the next thing we're going to do is go back to our VPC. We're still working in our producer account. Go back to VPC, and then we're going to go to endpoint. We're going to be creating the endpoint service. So this step is going to be bridging the network load balancer to the AWS PrivateLink infrastructure. So let's go ahead and go to endpoint services, and then let's create endpoint service. We're going to name this custom app service, and the load balancer type is going to be network. For the available load balancer, let's select our load balancer and then scroll down. And then here, this is very, very important, right? So here we're going to be checking acceptance required. And this is a critical security control because it ensures that even if someone discovers the service name anywhere, they cannot connect to our service without explicit manual approval from the provider accounts administrator. So this is very, very important for us to check this, and I'll show you where we're going to be accepting it. And then leave everything else and then create the endpoint service. Now that our endpoint service has been created, we need to come here and add allowed principals. So that way the producer account knows what account or what other accounts to allow requests to the services it's hosting. So in our case now, when we come here, we're going to be adding the principal of our consumer account here. So that way the producer knows who's going to be requesting access to the service it's hosting. In the real world scenario, this is where we now add the account principal names for other services that will be requesting access to this PHI. So in order to do this, let's come over to the consumer account. Come over here. I'm going to go to account, and then I'll copy the ARN of my account, and then come over here. I'm going to be allowing principals, so I'm going to click on allow principals, and then here I'll add the ARN of my consumer account and then allow principals. We're going to be making some changes, so we're going to change this account to root, and then also we're going to be changing the account here to IAM, and then let's go ahead and allow principals. So now that we've allowed the principal, let's copy the service name, and then let's go to the consumer account, go to the endpoints, and let's create endpoints. And this is going to be for endpoint services. I'm going to paste my service name here, and then I'm going to be naming my endpoints. And then here, let's verify our service name. There you go, it's verified now. Now let's select our consumer VPC, and then for the subnets, we're going to be selecting our subnets, and then let's select the private subnets. For the security group that's going to be attached to this endpoint, I need to make sure that it allows inbound HTTP traffic from my consumer VPC. So for this, I'm just going to go ahead and create a security group and then attach it to this endpoint. So let's go. So I'm going to go to security groups. I'm going to create a security group into my VPC, and then the inbound rule, I'm going to make sure it allows port 80 from my VPC CIDR, and I'm just going to go ahead and create. Now let's go back to our endpoint. Let's refresh and then select the one we just created, then create. So if you notice, right here, it's telling you the status is still pending acceptance. So our traffic is blocked right now until the provider account approves our connection. This is a security feature. That way no one can just come in and then send a request to connect to your private application. So right now we have to go to the producer account and then go ahead and accept this before it goes through. So let's go ahead and go to the producer account, still in our endpoint. If you come to endpoint connections, you will see it right here that is saying pending acceptance. And if you select it and come to actions, you can accept the endpoint connection. So right now, let's go ahead and accept it from the producer account and then accept. So right now, if we switch back to our consumer account and then refresh, now it's saying pending. Or allow the status to change. Now that it's changed to available, under details here in the same consumer account, under the details, we can locate the DNS name right here. So now this is the DNS name we're going to be connecting to be able to connect to the application hosted on the provider VPC. But for us to connect to this, let's launch an EC2 instance in the consumer account. So right here, let's go back here. Let's come to EC2 instances. Let's launch an EC2 instance. And this is going to be our test consumer instance. For this, I'm going to use Amazon Linux. I'm going to use T2 Micro. I'm going to proceed without key pair. And I'm going to edit, pick my VPC. And then I'm going to be spinning this up in a public subnet. And then want to make sure we enable auto assign public IP. And for the security group, we're going to be selecting the one we created since it allows port 80. And then go ahead and launch the instance. Now let's go back to the security group again that we just created. Let's go to inbound rules. Let's edit inbound rules. Let's also add SSH. Let's say SSH from anywhere and then save. Now let's go back to the EC2 instance. Now we're going to be connecting to the EC2 instance using Instance Connect, and then let's go ahead and connect. So right here we're in the EC2 instance. Let's go back to the consumer endpoint, and then we're going to be copying this first DNS name and then go back to the instance. We're going to call this DNS name, and if everything works out fine, it should take us to the application hosted on the producer private subnet. So the traffic is going to go through the network load balancing and take us to the private subnet, and we should see welcome to the secure provider service via PrivateLink. So let's go ahead and try it. This is a moment of truth. So let's go ahead and curl, and it's going to be HTTP, and then let's enter the DNS name, and then let's go ahead and enter. I'm gonna get the other DNS name. So this certainly has to do with the security group. Let's go back to our security group here. Let's see what our security group says. So our security group is allowing SSH. That's fine. HTTP from our VPC CIDR. Let's modify this. Let's edit this HTTP to come from anywhere. So now let's go ahead and test and see. So now I'm going to try and connect using the DNS name, and here it's failing. It's saying could not connect to server. So this may probably mean that our user's data failed silently and did not run or did not configure. So in the producer account, our private EC2 instance, I connected using the SSM session manager, and I'm trying to install the Nginx server manually. So here I'm going to check the status of my Nginx to see how if it was installed by our user data, and here it's telling me it could not be found, so that means it wasn't installed. But now I'm going to be installing it manually. But the problem is our instance is in a private subnet and cannot reach the internet. So right now the only way you can reach the internet is by adding a NAT gateway. So let's go ahead and add a NAT gateway to our producer account. So go to the VPC, go to NAT gateways, create a NAT gateway. So I'm just going to name it NAT, and then I'm going to select our VPC, and then for our subnet I'm going to be selecting the public subnet, and then I'm going to allocate an elastic IP, and then go ahead and create the NAT gateway, and then just give it some time to create. And while it's creating, we're going to go ahead and update our route table. So let's go to route table. So we're going to find the route table. This is the route table associated with our private subnet, and then let's select the route table. We're going to edit route, and we're going to add destination anywhere, and we're going to send this to the NAT gateway, and then go ahead and save changes. Let's check our NAT gateway if it's been created. There you go, it's available. So now let's go back and see if we can install the Nginx. So there you go, I'm installing the Nginx manually. And there you go, it's been installed. Now let's clear the screen. So now let's go ahead and start the Nginx. So system, let's go ahead and start it. And now let's go ahead and enable it. Awesome. So if you are building this project and your user data doesn't load and it fails silently, just go ahead and manually install the Nginx server. Here, let's go ahead and echo that into our index.html. So this is going to be echoed inside. Awesome. So now let's go ahead and check the status of our Nginx again to make sure it's good. Okay, it's active and running. Now let's check our localhost to make sure everything is working as expected. So right now we should see, okay, welcome to the secure provider. That's cool. This is what we expect to see. So now let's clear the screen. Now since our Nginx server is working, we have our security groups, everything configured. Let's go back to our EC2 instance here and then try. So this is our consumer EC2 instance, right? So we're going to be reaching out to the producer application privately using the private link, and then see if we can hit the application. So right now, let's go ahead and try the DNS name of our service, of our endpoint service. So if you come to our endpoint and go to details, This is the DNS name we're trying to get to. So let's go ahead and try that. And there it is. Welcome to the secure provider service via the private link. So that means we just successfully routed traffic from our consumer VPC in a different account entirely over the private AWS backbone into the provider VPC without a single packet touching the internet. So congratulations, you've successfully built a production-ready AWS PrivateLink architecture here. So just to wrap up, in this project, we learned how to publish an application using a network load balancer, expose it securely through VPC endpoint service, and privately consume it using an interface VPC endpoint. And more importantly, you saw why AWS PrivateLink is one of the most secure and scalable ways to share services between VPCs and accounts without exposing our network or even relying on traditional connectivity methods like VPC peering and transit gateway. You saw that the producer had to accept connection from the endpoint of the consumer account. And that is the power of AWS PrivateLink. It's unidirectional, meaning the provider can't reach back to the consumer. So the producer account can't ever reach back to the consumer. So in our example, the PHI stored can't reach back to the applications. Only the applications can request PHIs from the producer account. It also ignores overlapping IP addressing and it keeps your attack surface incredibly small. So this concludes our project. Thank you for watching. If you found this video helpful in any way, please give me a like, subscribe to this channel for more videos. Project 39 is going to be coming up, which is going to be IPv6 enabled dual stack architecture on AWS. Thank you for watching and have a great day.